For section 8.4, we're going to look at something called an annuity. So annuities, methods of savings and investments. Largely, we're going to talk about annuities, and then we'll talk very briefly about reading a stock table. Okay. So here's the predicament we find ourselves in. We know that we need to plan for some big something down the road. We want to buy a house, we want to retire, we're going to have a kid, we want to send them to college, whatever the case may be. Okay. But in order to save a lot of money, we have to have a lot of money to invest, right? So the more you invest, the higher the interest rate, the more money you'll have down the road. But that's not realistic for a lot of us. A lot of us can't come up with $20,000 today so that we can have $30,000 down the road. That's just not realistic. So this is where an annuity comes in. An annuity allows you to consistently make payments towards a savings plan. So instead of coming up with 20 or 30 or $50,000 today so that you can have a certain goal down the road, maybe you could come up with a few $100s a month or $1,000 twice a year, something like that. So an annuity basically allows us to make regular payments into this account so that it will accumulate to a goal down the road. Okay. So again, I say this a lot. You know, I love to start with a good definition. So let's get to it. So when we have these annuities, please understand that an annuity is a sequence of equal payments made at equal time periods. So you have some set payment, maybe $500, and you're going to make this every 3 months. So there's some consistency here. The payment's going to be the same, the time period's going to be the same. Okay. The value of the annuity, so that's going to be how much the annuity is worth at some point down the road. The value of the annuity is the sum of all deposits plus all interest earned. So how much did you put in there plus any interest that has accumulated over time? Okay. We have a very common type of annuity called an IRA, which is just an individual retirement account. It's just a type of an annuity. Okay. So things we need to know. A lot of the variables that we're using mean the same thing that they've always meant, okay? But there are a couple of teeny tiny tweaks that we need to understand, okay? The first tweak we need to understand is N, okay? N represents how many payments you're making to your annuity each year. So if you make a monthly payment, N would be 12. If you make a semi-annual payment, N would be 2. If you make a quarterly payment, N would be 4. So it works very similar to a compounding period. Just understand that N represents how many payments you're making in a year, basically. Okay. And then P is a little different. We've talked about P as present value a lot. We've also talked about it as the principal. When you're dealing with an annuity, P represents the amount of your regular deposit. So if you're making a $500 deposit every month, P would be 500. If you're making $2,000 payment every quarter, P would be 2,000. Okay. So P represents the amount of the regular deposits and N represents the number of payments made each year. Okay. So they work in a very similar fashion to the way they worked every other type of example we've done in sections 8.3 and 8.4, but here, slight tweaks. Okay. So do not be alarmed by the formula. The formula is nasty, okay? We're not going to try to derive the formula or figure out where the formula comes from. We just need to know how to use the formula. We need to know when to use the formula. We also, and this is very, very important, we need to know how to type the formula into the calculator all at once, okay? So I am going to write this down here because this is important. Type into calculator all at once. What you cannot do, okay, and hear this loud and clear, what you cannot do is calculate little pieces of this formula and round them and then put a bunch of rounded values together at the end because your answer will be way off. We have something called round off value. So when you're using a formula, the more times you break that formula apart and separate it, the more round off error you're going to have. And it can make your answers really quite different than the accurate answer. So you need to learn how to type these formulas into a calculator or into Desmos all at once. You type it in one time and then hit enter one time and you get your answer. Okay. Now, we also need to be able to calculate interest. So interest is kind of interesting. Okay. When you're calculating interest here, you're not using the simple interest formula at all. What we're doing is we're figuring out what the value of the annuity is, and that's still going to be A. So we're still going to use A for future value. Okay, so A represents all of the deposits you've made plus everything that has been earned over time. Okay, so what we have to do here is we have to figure out what the future value of our annuity is using this formula on the left-hand side of the screen. And then from that, we subtract everything we put in. Okay, so A represents the entire value of the annuity. And then we're going to take P, which is our regular payment. We're going to multiply it by N, which represents how many times we made a payment per year. Then we're going to multiply that by the number of years we made this payment. So you basically take the full value of the account and subtract your contribution. Okay. So this is the full value of the account. And this is the value of your deposits. And the difference between the two is how much you earned in interest over a set time period. Okay. So let's go ahead and look at an example. Okay. So starting at age 25, you decide to deposit 500 every quarter into an IRA. Remember, that's individual retirement account that pays 4%. 4% is steep. You're probably not going to find a 4% IRA. Just keep that in mind. Okay. So the question then goes on to say, how much will there be in the IRA when you are 65? So let's figure out how many years will have passed. So you're going to start this when you're 25. You're going to end this when you're 65. Hopefully you retire at 65. So 65 minus 25 is 40, and that's going to represent T, the number of years. Okay? Now let's figure out what all of our other variables are going to be. We know we need P. P is the amount of your regular deposit, so P is going to be $500. We know that R is going to be whatever the interest rate is. That's not going to change. Okay, that's going to be the same consistently throughout this chapter. So R is going to be 4%, or for us, 0.04. T is time in years, so we know we're going to do this for 40 years. And the last little piece of this puzzle that we need is N. N is the number of times we're going to make a deposit per year. And what we are told is we're going to make this $500 deposit every quarter. In 1 year, there are 4 quarters, so N is going to be 4, okay? Now, let's take a gander at that formula, okay? So this is the formula we're using. It's nasty, but I'll show you how to type it into your calculator, okay? Whoops. So we have A equals P, which is 500. And then you want to do one big set of brackets and then immediately start your inside parentheses. So brackets and then parentheses 1 plus 0.04 divided by N. Remember, N is the number of payments you're going to make per year. So N is 4. We're going to raise that to the 4 times 40 power. Remember, N is 4, T is 40. So we're going to raise this to the N times T power, which is 4 times 40. And then we're going to leave the exponent and we're going to subtract 1 from this whole thing. And then we divide all of that by the interest rate divided by N, which is 4. Okay? And we want to type this entire thing into our calculator all at once. Again, you can't piece this together. You can't take a little piece here and round it and a little piece over here and round it and then a little piece over here and round it and then put it all together at the end. You will not get the right answer. Okay, so let's switch screens. Let's go to, this is definitely going to be easier in the calculator, but I'll try to show you Desmos as well if we have time. So in the calculator, okay, so we're in the graphing calculator. The first thing that I'm going to encourage you to do is get your calculator to pull up the fraction template. Okay, there's a couple of ways that your calculators will do this. I generally do the most generic version so that it works across the board on different calculators. So what you do is you go alpha and then y equals. So alpha y equals pulls up this menu here, and you want to choose the first option, which just does a regular numerator divided by a denominator. So you can either hit enter or you can hit the 1 button. I'm going to hit enter. So now we have a template. Our numerator, remember, we're going to start with whatever P was. P was a $500 deposit. And then you want to start your brackets, so just regular parentheses, and then immediately inside those brackets, we had another set of parentheses, so we want to start that next set of parentheses, and we're going to go 1 plus, and then we've got R over N, so 0.04 divided by 4, end your inside parentheses, okay? Now we need to do an exponent, so we're going to do the little caret button above division, and we want to go 4, which is N, times 40, which is T, and then we need to leave the exponent. So we're just going to hit the right arrow. We're going to subtract 1. And then we're going to end the brackets. So end your parentheses again. Okay. And then for the denominator, just hit the down arrow to go to the denominator. And then I go ahead and put this in parentheses. I don't think you actually need to, but I tend to overuse my parentheses. So we're going to go parentheses, and then we want R divided by N as well. So 0.04 divided by 4, end your parentheses, and then hit enter. And when we hit enter, this will give us the full value of our annuity after 40 years. So hit enter. And we can see that after 40 years, we've got $195,691 and approximately 32 cents. I will tell you, read directions when you're dealing with annuities because sometimes, not always, but sometimes annuities will tell you to round to the nearest dollar. Here we're going to go two decimal places. So we're going to do normal rounding for money. So $195,691 and 32 cents. So let's go back to the worksheet. Okay, so the value in our annuity after 40 years is $195,691.32. And this is reasonable. If we were doing just one single investment account, we would have to put tens of thousands of dollars into an account to 40 years later have 195, almost $96,000. Okay, but being able, and that's not realistic for most of us. Most of us don't have tens of thousands of dollars sitting around waiting to be invested. But a lot of us could realistically come up with $500 every 3 months that we could put into an annuity. So this makes saving for something big down the road, like retirement, this makes saving for retirement realistic for a lot of us. Okay? Now let's look at the interest. So remember, with the interest, we want the value of the account minus our contribution. I'll put our contribution is $500 every 3 months for 40 years. So the value of the annuity is $195,691.32. Our contribution is $500 every quarter, so that's 4 times a year. So 500 times 4, and then we did this for 40 years, okay? So doing a couple of calculations, just kind of on my handheld calculator instead of switching screens. We have $195,691.32. We know that's the value of the annuity after 40 years. Let's figure out how much we put into that. How much is our personal money? So we have 5,000 times 4 times 40, which is $80,000. So of that $195,691.32, 80,000 of it was money that we put in. The difference is the amount of interest you earned over 40 years. So the difference is 115,691, hold on, 691.32 in interest. So over the course of 40 years, you came up with $80,000 total. You did this in small increments, 4 times a year, every year for 40 years. And then over those 40 years with 4% interest, which is unrealistic, it probably would not be 4%, it would be much lower than that. But you ended up earning $115,691.32 in just interest. Okay, so this is the beauty of an annuity. Most of us don't have tens and thousands of dollars that we can invest today in hopes of having much more money 40 years from now. But many of us, if we work hard, could come up with $500 every quarter that we could deposit into an annuity so that 40 years down the road, we could have some money to retire on. Okay, so that is kind of just a general example of an annuity. Let's look at one more. The second one will go through a tiny bit quicker. Okay. So for example 2, it says starting at age 30, you deposit $100 every month into an IRA that again pays 4%. I want to say this again, 4% is probably pretty steep, okay? So how much will there be in the IRA when you turn 65? First thing we want to do is figure out what T is. So how many years are we going to make these deposits? So we hopefully retire at 65. We started doing this at age 30. So that right there tells me that 35 is T. So we're going to do this for 35 years, okay? Let's find the other variables. So P represents the amount of your deposit. So how much is your regular deposit? In this case, it's $100. We already know that T is the 35 years. R we have is 4%, so we're going to write that as 0.04. And then N tells us how many times we're going to make this deposit per year. We're going to do this monthly, so N would equal 12. So when we use the formula A equals, this tells us the value of the annuity at some point down the road. So for us, it's going to tell us how much is in our annuity in 35 years. So A equals P, which is 100, brackets, and then immediately start parentheses. We have 1 plus R, which is, R, which is 0.04, divided by N, which is 12. We're going to raise that to the 12 times 35 power. So we're going to make this payment 12 times a year. We're going to do it for 35 years. We want to leave the exponent and subtract 1 from that whole thing, end our brackets, and then we're going to divide this by R over N. So 0.04 divided by 12. And I just noticed I made a tiny goof up here. In the formula, instead of putting the actual N, we want to put 12. Okay? So your formula should read 100 brackets, immediately parentheses, 1 plus 0.04 divided by 12, end your inside parentheses, raise that to the 12 times 35 power, leave the exponent, subtract 1, end your brackets, and then your denominator should be 0.04 divided by 12. So let's go back to the calculator and try again. So we're going to do this all over again. Now I'm going to start this formula from scratch. So we want to go alpha y equals, that pulls up the fraction menu, and we're going to choose the first option. That gives us just a template to work with, which makes this a little bit easier to type in because these can be pretty nasty to type in. We want to type in P, which is 100, brackets, and then immediately parentheses. Now on your calculator, it won't differentiate brackets and parentheses. You're just going to see double parentheses, but it should look exactly like what you see here. And then we've got 1 plus R, which is 0.04, divided by N, which is 12, end the inside parentheses. And then we're going to raise this using the little caret button above division. We're going to raise this to the N times T power, so 12 times 35. We're going to leave the exponent, so hit the right arrow, subtract 1, and then end your brackets, okay? And then just hit the down arrow to go to your denominator. And like I told you in the previous example, I tend to overuse my parentheses. So parentheses 0.04, which is R, divided by N, which is 12. End your parentheses and hit enter. Oh, I see what it is. I've got a little goof up here. Excuse me, there's a big old goof up here. So what I'm going to do is where I go back to my screen, just go up until you have your formula highlighted if you typed it in like me, which was kind of boneheaded. And then up here, hit the right arrow until you get to the top. I'm going to have to type in my -1. I typed in my minus and then didn't get my 1. So -1, and then I'm going to end my parentheses, hold tight. Okay, hopefully you got yours in right the first time, but I had a little typo, we'll say. And then hit enter, and we get that after 35 years in our account, we're going to have $91,373.09. Okay, so nothing here said round to the nearest dollar, but do be on the lookout. Sometimes for annuities, they'll tell you to round to the nearest dollar. Here, we're just going to go 2 decimal places. So moving on to the worksheet screen. All right, we have 91,373 and I guess just 9 cents if I remember correctly. I don't think we had to round up here. Okay, so there we have it. That's how much is in your account after 35 years of making monthly deposits of $100. Okay, let's calculate the interest. So remember, for the interest, we have the full value, like the total value of the annuity. So that's A, minus your contribution, which is the value of your deposit, times the number of times you made a deposit per year, times the number of years, okay? So for us, we're going to get $91,373.09. We want to subtract 100 times 12 times 35. So I'm just going to use my handheld instead of switching screens again. So what you would want to do at this point is type in 100 times 12 times 35. That tells me that we personally deposited $42,000 into this account over 35 years. The difference in the full value of the account minus our contribution is how much interest this account earned over 35 years. So we ended up earning $49,373.09 in interest. Okay, so make sure you understand how to calculate what is in the annuity. That is using that A equals formula, and then understand how to calculate the interest, which is taking the value of the annuity and subtracting all of your deposits made over time. Okay, so there you have it. That is an annuity. Again, the idea is that we may not have tens of thousands of dollars to invest at age 30 so that 35 years down the road we can retire, but we could realistically, with hard work, squirrel away $100 a month that we could deposit into this annuity so that we could have some retirement money down the road when we turn 65. Okay, so that is calculating an annuity. In the next video, I think we're going to look at kind of planning. So we're going to know what our future goal is, and we're going to know the terms of an annuity, but we've got to figure out what our monthly deposit would need to be. So we'll do that in the next video.